Hey, brother. Recording. Okay. I just started recording. So let me share my screen again. Please confirm that you are able to see my screen.
Yeah, we can see so.
Okay. Yeah. Thank you. Hello. Welcome, everyone. Today we are little deep diving into the infrastructure as a code, a method that treats your infrastructure as software. As you guys already know, and if somebody not known, so I'm Srinivas Rao Reddy, working as an architect in Clorox, and over the next 30 minutes, we will see why IaC is, I mean, like infrastructure as a code is a game changer for IT teams. All right, in this session that we are going to talk about the modern automations and the best practices, and I mean, like exactly that IaC little deep dive inside. Okay. Okay, so basically, like, what is IaC? And past two sessions, I think we were talking about the automation side and the DevOps practices. So in that, IaC is one of the part as a part of DevOps, and basically, like IaC, like here we are talking about infrastructure, but it is also applicable for the application side as well. But basically, like the provisioning and how we are going to manage the computing of infrastructure through machine readable and configuration files rather than manual process. So I mean, like generally, like um, when we have to configure and compute, and I mean, like anybody asks for the particular resource to deploy it or provision it, people will be going through different processes, like through the service request or Jira. I mean, like based on the environment or the infrastructure process. I mean, like organizational process, they will create the requests. So in that case, it's like just to take it as an example, best ITSM tool is ServiceNow. So in that, like people will be generally going with the ServiceNow service request, then they will provide all the requirement. And after that, operations team or the IT support team, they will look into it, and based on the availability of the respective provider, whether it is a cloud or on premises, they will go and check the availability of the resource, and manually they will deploy it, and the required packages they will install it manually, and then after everything is working fine and after verification, they will provide the access to the respective requester by following certain guidelines. So that is the generally process. But in this case, like there is a possibility like we may miss some of the steps, or we may not be knowing like some of the resources available. I mean, like available in the sense like somebody might have already utilized, and we cannot reutilize and all. So to avoid all those things, here we are coming up with the technology called infrastructure as a code, whereas like we will be doing, or generally as a part of DevOps, infrastructure as a code will do the automation for the provisioning and the configurations, and whatever the deployments required, it will do that as a part of the process. The key benefits is like infrastructure as a code is like it's a blueprint for IT environments. For instance, rather than manually setting up AWS EC2 instance or um, Google Cloud Compute instance or Azure uh, virtual machine. So by using the configuration file with the versionized and automatically deployment, we can do that automatically by avoiding the human errors and all. So the advantage that we can see that it's the consistency and repeatability. Like it is not like one day job that we can do it and leave it further. So keep as the infrastructure and the compute grows, we need to do it. This is repeatedly. So that is where that we can see that automation possibility. And also, once the request is submitted, generally people or the team will take a lot of time to deploy it. So in this case, it's like by following these guidelines as a part of IaC, we can see that faster deployment. And in case of any failures, that we can recover quickly by following certain guidelines for the backup. Even we can go back to the older version or we can update the version. So that is where infrastructure as a code is a game changer in the current IT for deployments and the resource configurations. All right, going to the next um, slide. Like, what is the importance and the best practices of the infrastructure as a code? So why we need IaC and what are the best practices that we can follow? Like, as you have specified, like this is not a one-time job that we can just configure it and leave it. This is everyday job where whether it is through service providers, with the cloud organization or on premises or in a hybrid environment or in private cloud, we need to configure the compute to accommodate whatever the functionalities that we are looking for, whether it is a serverless, which is server-based applications or any kind of, the database organization or application-based instances. All these things are the requirements every day. So that is why we need this. Like the infrastructure with the infrastructure as a code, we can reduce the human errors, and also like because we are um, keeping that libraries or once the template is ready, that will be repeatedly used and that can be versionized based on the requirements or like with the for the future is use as well. For that reason, that we will be using the version control system to keep the version history of the script file or the infrastructure as a code automation, the configuration files. And also, when there is sometimes like take it as an example, like in previous sections that I have explained about, like during the peak hours, some of the instances, it will be required to increase the compute, like whether it could be a CPU or a memory, or sometimes it could be a disk. So during the business hours, it is required to auto scale. And again, once the it comes back to the off peak hours, then it has to be reduced. So with infrastructure as a code, it is very much possible that we can do it. So that is where like this infrastructure matters a lot. So with like the best practices that I can say that as whether it is infrastructure as a code or in the software procedures as well, always keep it as a modularized and which is the code should be reusable, kind of like microservices or keeping it as a small functions where we can reuse it, kind of like the general templates that you can keep it, and wherever it is required, just configure it by uh, calling that particular uh, modularized function or API that we can say, whatever the microservice, and then we can reutilize it. And again, like keeping this files and the software in a version control system, it will be useful further to control the complete releases, whether it is a we have done any changes and somebody else are doing some changes and which may corrupt something, that we can control it by using Git or GitHub or any version control system. Like we can go back or we can update it. So yeah, I mean that is a basic advantage of version control system. It is applicable for all the development activities, whether it is uh, application development or infrastructure as a code or any deployment activities or configurations, that keeping it in version console system is the best practice. And again, like once after coding or once we kept it in the version control system, we have to make sure like it is working fine. I mean, like whatever the code that we have deployed or the automation script that we have developed, that should be tested. It should be well versed with the testing, and we have to make sure like it is integratable with in different phases in the SDLC. I mean, like software defined. I mean, software development life cycles, like whether it is modularized, like at the unit test level or integration test level or the system test level, whatever is required, it is working fine. So based on that, the deployments and between, I mean, the deployments between the environments, like whether it is a development or it is in QA test or before production, like the stage environment, that it should be deployed. For that reason, we have to make sure like it is, we are doing this thorough testing. And whatever the changes that we are doing, it has to be documented just by seeing like maintaining the release notes or release uh, versions and all. If we can keep it, that will be helpful. Like what are the changes is that we have done that will be versionized, and everybody knows like whether it is, if it is a bug fix or if it is a new feature that we are adding it. If we can keep it in the release notes or configuration details in the note, if we can document it, is that is again a good practice. Like the production environment with the Git or CI/CD, you can push the changes to repository. So I mean, like when you are updating it to the production, so automatically runs the test and deploy the changes without manually configured for every server. So that is the reason, like maintaining the version control system and CI/CD pipelines into the environment properly configured and following the process and the flow will be the best for infrastructure as a code. All right, I think probably if you guys have any questions, you can contact me, or if time permits, that I can take up some of the questions at the end of the session. I'm going to the next slide. So, I mean, what is the declarative and imperative approaches? Like, I mean, like what is the desired end state that we need to focus, and what we want to achieve it, and I mean, like how figure out like where or how we can address our um, requirement. Example, like just an example that I'm taking it as like Terraform configuration is state. I think like some development activities or development people, they may come up and saying like that, I need 3 web servers running. They will just give an one singular statement where we need to collect some of the requirements, like what web server he needed and what kind of ports that he need to access it, how he want to access it, whether it is going to be inside or outside, and what is the I mean the expected process or the compute he is expecting. All those things that we need to collect it as part of declarative approach. And imperative approach is like I mean, like in case once the um, web servers are provisioned, what exactly that he's going to do it. Like, I mean, like whether he's going to run some commands or any activities that he want to do it. Like, what kind of the servers, I mean, like what access that need to be provided. All those details will come as a part of imperative approach. I mean, like how the configuration should be like that. That level of details that we need to um, collect it and follow that process or the approach as part of imperative approach. And yeah, I mean, here I can say like uh, Terraform. I'm just referring it Terraform because it is a cross-platform which can work with any of the I mean the service provider, and it doesn't have any dependency with any of the um, service provider. Take it as an example, like AWS Cloud Formation, it works only in the AWS. Azure DevOps, that works only in Azure environment, and GCP uh, management, I mean like a manager server or management tool that has it works only in the Google Cloud Platform. In this case, so Terraform is the generic, and also we have Pulumi and some more which works cross platforms. So so for the example that what I'm referring here, Terraform is like we will be writing a configuration that states your desired infrastructure, and that contrasts that with an imperative script where you would manually write out every command. This makes declarative code easier to maintain, less error prone. So just an example that I gave here. So, but that is how, I mean, like the use case that I can refer here with the Terraform. Let me go to the next one. Okay, as I was saying, like the infrastructure as a code with the we have some tools. So Terraform is playing major role here in this case, and we have some more as well that I will be bringing in the next slides. So for the formation, I mean, like whether if we want to go with cloud formation or Azure or Google Cloud, Google Cloud in a compute instance, Terraform will support it. So this is basically Terraform. Why people are using Terraform is like it is not service provider based, and it's an open source tool that uses a declarative language like HCL that we are I mean, like it's a kind of like a HashiCorp limited one, and emphasizes its ability to manage infrastructure across multiple providers, as I specified. And it's very, I mean, like uh, everything that we can do it as a modular way, and it maintains a state machine like configurations and all. We may not put it into the version control system, but the state machines here, the state machine is like once the resources has deployed, it should not be reprovisioned again to maintain that resources, what states it is, and how exactly it is running, how much usage is happening. All those things will be captured and maintained with the Terraform state machines. Um, so just an example that I'm probably can share with one of the code snippet where you can see like AWS instance, how we can deploy it by using Terraform. Hope you guys are able to see the screen now. So just say this is just an I mean the very simple code, like what is the provider that we are using, which region that we are going to deploy it. So whether it is US East or because all the cloud providers will work on based on the regions, and it will be allocate some resources based on it. Like this is like AMID, I mean that's image where which region that we need to deploy it. What is the test AWS instance that we are planning to use? It's a web server, and also the instance type. So like T2 micro means like it will be having the configurations like T2 micro or macro or mini and all. So where based on that instance type, you can see like how many CPUs has been allocated, what is the RAM and the memory, how much is been allocated and all. Based on the requirement that we can change it and um, and we can accordingly we can provision it. So here, I mean, just a tag that we have specified this, we can say it as per the applicability, what exactly the tag is. If you run this command with the Terraform, run this one in the Terraform CLI, you can be deployed one AWS web server with this AMI and the instance type. Just running this one in on a CLI, you will get one server and one web server. Of course, there are some initial I can say that states or some of the commands that we need to take care of it. So I mean, which it will be run with the main.tf files where it should have all these details. And after that, you can run different kinds of commands to apply and to deploy the such web server in this case. I will discuss later on, like in the coming slides. Okay, let me go back to the presentation. Hope you are able to see this screen, right? Like whatever the code snippet that I'm seeing sharing here. Okay. All right. Yeah, this is AWS native. Like this is kind of like a AWS cloud formation, like how exactly it is. Good. Thank you for the confirmation, Vishwa. Um, AWS, how in AWS, how exactly that works, like the cloud formation. AWS cloud formation is the infrastructure as a code tool there. Like, internally how it works is like whether it could be a JSON or the YAML file, the templates it will uses, and simply it will deploy the AWS resources. Just now I showed one of the file where you seen, you might have noticed it, like that is with the Terraform. Similarly, that we can run on the AWS CLI or through AWS GUI by converting the same thing into YAML file. Let me show that in the code snippet as well. Okay. Yeah, the whatever that I have just now specified another Terraform, right, script. See that same thing that we are doing it here by running this YAML file. So this works perfectly on the AWS environment because this is specific to that AWS with the cloud formation. Similarly, I think even for other, sorry, I was talking about Pulumi, right? So this is another tool which works as class platform again. And the scripting it supports with the import functionalities of Python. And basically, when you are developing any kind of uh, Pulumi script files, the file extension is .ts, which is TypeScript. And it works perfectly with Python, Go, and other languages as well. And it has imperative programming features with the infrastructure as code. By using Pulumi script, I think probably you can write whatever we want, whether it is AWS or Azure or GCP. Let me show back how the code structure will be in the Pulumi, because most of the things, like it's mostly like human readable format, but only thing is like the keywords which is required that has to be placed. Okay, I think the same instance which I was talking, how we want to develop through Pulumi TypeScripts. This is the structure. So, we are just importing it from the AWS with the Pulumi module, which has been integrated. And after that, these are the these is two instances for what that instance that we are developing. That is for the web server. What is the instance type? Say T2 micro and the image ID, AMI ID. So that we are specifying it. Mostly most of them all are similar, but only thing is like little changes in the syntax. But all this works perfectly with the infrastructure as a code. Okay, let me go to the presentation now for the next one. Yeah, I think I was talking about the state management in the Terraform, right? So, like, once the resources are deployed, and we are not going to provide any information in the version control system for the resources, whatever has been deployed in the configurations as well, like what is the IP of address of that particular uh, machine, I mean like virtual machine or the server or the instance, and whether it is what it is running, and how much is getting utilized, and all these details we are not going to put it into the version control system. That has to be maintained in the state files. I mean, that is the state management in the Terraform. Like, I mean, this is very critical to track the current state of our resources. Okay, I think I've got a reminder. Let me go quickly. Um, we have different kinds of state machine storages, like, I mean, like, especially like the local and remote. I mean, like, especially if we are deploying any uh, S3 bucket with DynamoDB for DB, I mean, like, for logging, it helps. I mean, like, in that case, like, people will be preferred to keep it as a local or remote state, because they want to prevent the multiple team members to for overwriting the changes simultaneously. So, I mean, like, once it is done, and it has to be versioned, and again, I mean, like, versioned in the sense like it will keep track of it, and it is inside the AWS itself. And other person, whoever is running, it will keep another snapshot of that. So that is how the state files has been mentioned. Okay, the best practices as it's specified, like, I mean, like, keeping the S3 DynamoDB for logging system. Like, one person is writing on it. I mean, like, where it's storing some database into that, and so other person should not access that. I mean, it will be logging until the first person is completed. After that, another record can be uploaded into that. The next whoever is waiting in the queue. So it will be like a queue management that it has. It will be applicable for this backend state machines. So that is how it is controlled. And also, like, when some person is accessing it, how he is communicating, like how what kind of keys that he is using it. So in that case, it's like the secure state files will maintain the key files, and with that keys only, it will get accessed, and it will the private case that I can say that it will be dedicated for each user or the transaction, and that will be stored into the S3 DynamoDB. And with that only, he can access it with their identity. All right, let me go to the next one. So the best practices for IaC, like, I mean, infrastructure as a code, like, for every stage that we have to make sure, like, state files are being maintained, at the secrets, the keys, which I was talking, it has been maintained. And it has whatever the code it is being deployed, it has to be done through the review and reviews. Like, I mean, like, once somebody is developed a module or some function that has to be reviewed before merging to the version control system. And once it is applied to the version control system, it has to be automatically scanned for any vulnerabilities or any code dependencies. And while integration, it should not create any problem. And also, it should not be, I mean, for security wise, it should not be vulnerable. And also, if some people might be accessing by you writing some static codes, or defining some variables with some values, and also are some privileges that they will provide it inside the code, that is not advisable, and it's not a best practice always. And that is where, like, this code scanning tool will verify it, and they will scan it and provide the report and say that it is a risk, so you should not use it in this process. So that is where this automated scanning will help to detect all this stuff. Okay, so I mean, for the best practices, like, we need to integrate the security tools, and static analysis to detect, I mean, that tools, whatever that is going to introduce, it does static analysis to detect the vulnerabilities, and also it will monitor and provide the audit report, whatever the changes that it is doing it. Like HashiCorp um, Vault has a securely stored secret referenced in the Terraform files. Additionally, I mean, like it's secretly stored and it can be accessible only through that variable, but not visible to the anybody else. It's encrypted. All right, let me go to the next one. Okay, manage multi-cloud environment with IaC. Like as I specified, like we can do with multiple things. I mean, multi-cloud environment that can be supported by using the IaC. I mean, like in the same Terraform file, based on the requirement, like whether it is Azure or it's AWS or it's GCP, we can deploy the server based on the, service provider configuration. So here I have the code, but please be, I mean, like in case if it is got disconnected, I can share it separately as well. So, I mean, just for example, that I have created separate files for everyone. I mean, Azure, how RM, how it looks like, and GCP instance, how it looks like, and what are the things that we need to consider while deploying um, any virtual machine in the Azure platform, and similarly that in the GCP compute instance. So what exactly that minimum requirements and how does code looks like, that I have drafted here, but we can take one development environment and we can see that, apply it and see that how exactly it works. But for that reason, I mean, like to do that activity, we should have access to that GCP instance or Azure, GCP cloud and Azure platform and AWS platform. Then only we can run this code. This is just for the reference that I have created here, but this works perfectly. And also here in this case is like we have to migrate as per our requirement, like whether it is going to be the same region, what kind of instance type, and like where is the zone and all. So some of them are similar, keywords are different, but everything, the underlying concept is same. That is the multi-cloud environment with infrastructure as a code. And okay, I think this is what I thought. Like, let me walk through that. But in this case, is like uh, how Terraform works. So let me go back to that code window. So here I'm saying like the main.tf file where I'm trying to deploy one of the web servers. So in that case is like what are the rules that I need to set it, and what is the egress rule, ingress rule, and what kind of port it is required, and what is the VPC ID, and also like how what is the instance type that I'm declaring it. And in that case, it's like once it is done, I mean, like even for that web server, we need to install some of the web processes, right? That can be done through this commands. And these are all in the Terraform file. To run this, once the Terraform initiation and from the CLI, we need to run these three, like Terraform initiation and the Terraform plan and Terraform apply. Once these two steps are done, and in case if we are modifying something here, then you want to apply it again, then you can just run these two commands, Terraform plan and Terraform apply. It will be reflected. So Terraform init will do little code checking and all. I mean, like just whether everything is fine or not. After that, once you apply it, and in case of any problems or errors in the code, it will be identified accordingly. You can fix it and then you can apply it. So this is the, I mean, like normal process in the basic way that we can follow that. All right, I think state files we discussed, I mean, managing the states and all, and how the Terraform apply and the deploys will work, that we discussed. Yeah, I think the key takeaways that I can say, like, I mean, the uh, infrastructure as a code, that automation and consistency and scalability is the key benefits in this. And again, like importance of the security and best practices that we discussed. And I think uh, I would like to hear about some of your thoughts, but to get more details. So these are the some additional references that you can go ahead and uh, check that. It has a lot of details if you are the first time that you are using it. Sorry. Okay. First time if you are using it, that you can go here and check that the Terraform documents as well as the AWS document, and follow me in case if we want to use it, that how those details also available here. In case if you have any questions that I can help you, here are my some of the contact informations, and that you can browse and you can get the details, and you can connect me and you can post your questions that I can talk or I can help you guys when it is